So let's look at matrices. Today our discussion is on how numbers are arranged according to the rows and columns. That's what we describe by what we call matrix. Now we have the question here. Such questions, we can take a look at the question very well. You'll see and discover that in grade 9 this question comes in math paper 1. And many times they'll also look at questions that comes in math paper 2. But in the meantime, we're going to have this question that comes in math paper 1 on matrix. Let's see how we can solve this problem. Given that the matrix A is negative 2, 3, 4, 6, 5. State the order of A. Stating the order of a matrix, there's a procedure that we have to put into consideration. And that procedure is that we must look at how many numbers of columns, of rows do we have by the numbers of columns. Look at this question here. This is our matrix we have here. How many columns? These are columns here. 1, 2, 3 are columns 1, and 4, 6, 5, second row. I mean 1, negative 2, 3, 5, these are rows, and 4, 6, 5, these are rows. Here we have 2 rows. By the number of columns. How many columns are we having there? Negative 1 and 2, negative 1 and 4, first column, 2 and 6, second column, 3 and 5, third column. So we have 3 columns there. So this is how we state the order of the matrix. It's row by column. Rows, 2 rows by 3 columns. So in other words, you can express this answer as O 2 rows by 3 columns, meaning that this R represents the rows and C represents 3 columns. This is how you can answer that question. Now let's look at the second one. Find negative 2A. This is a scalar matrix. A scalar matrix is a situation where a number multiplies all the elements in that matrix. You say negative 2A is equal to, this is negative 2 outside the matrix. We have a negative 1 here, we have a 2, and we have 3. And we have 4, we have 6, and we have 5. Here, meaning that this number, negative 2, is a scalar matrix. Meaning that this number must multiply all the individual elements in this particular matrix. Meaning that this number, a negative number, should multiply individually the numbers by saying that this negative 2 multiplied by negative 1, the result will be 2, positive. We understand that positive, negative by negative is a negative result. It's a positive result. And then negative 2 multiplied by 2 here, it's a negative 4. The negative 2 multiplied by positive 3 is a negative 6. Then we come to the second row down here, which is 4, 6, and 5. And we'll do the same. Negative 2 multiplied 4 is a negative 8. A negative 2 multiplied by 6, a negative 12. A negative 2 multiplied by 5, a negative 10. So this is the value of negative 2A. This is the final answer. This is how we find problems in math paper 1, where you are asked to state the order and to find the value given by a number multiplying a matrix. It could be a fraction at times, it could be a number. So this is how we calculate such problems. But the emphasis is on this part. When a matrix has been given, the first thing that you have to consider whenever you ask to state the order of the matrix is to count how many rows does this matrix has. Then you count from there. Here we have in 2. There are times we only have 1. There are times maybe we might have 1, 2, 3. These are only matrices that we have. How many rows can we count? We only have 1 row, which is 1. How many columns? 1, 2, 3. So this becomes 1 by 3 matrix. Yeah, so they can be different in different ways, styles prepared in different way. But this is how to solve them in math paper 1. Yeah, so let's look at multiplication of matrices. Yeah, so addition and subtraction, the way we add matrices and the way we subtract matrices is one of the same, in a similar way, but the way we handle multiplication is different from addition and subtraction. Multiplication, the way of multiplying matrices is law by column. So I'll show you how to go about multiplication of matrices. So in these matrices we have, there are 2 by 2 matrices. We have 2 rows and 2 columns. Each A and B have the same order of matrix. So in finding the value of the matrix of AB, we'll say our AB is equal to, we combine. Our A is 1, 2, 0, and we have 1 there. And our B there is 2, neg 1, we have 3, and we have 2 there. So just doing this, doing an exam, I know this question comes in math paper 2, where we have addition, subtraction, and multiplication. And this question carries 3 marks. You doing this, you have a 1 mark, just by grouping them together during the final exam. And thereafter, you can just say, you say multiplication, AB is equal to, you now say multiply 1, this row multiplies this column. This row multiplies this column. The same row multiplies the second column. So we'll say 1 multiplies 2 plus this 2 here multiplies 3 here. This one times this one plus this one times this one. It's 2 multiplied by 3. We leave a space here. This is, we're done with the first column. We move on to the second column, which is negative 1 and 2. We multiply by the same row we have there. So this 1 times negative 1. So 1 times neg 1 plus 2 multiplied by 2. Then we come to the second row here, which is 0 and 1. We'll do the same. 0 multiplied 2. 0 multiplied by 2 plus 1 multiplied by 3. 1 multiplied by 3. As you multiply, the last numbers you're multiplying, it must be the same. Check. 2 is 2 here, 3 and 3 here. So this shows that we are actually on the right track. Then we are done with the first column. Let's multiply the second row with the second column. We'll say that this 0 multiplies this negative 1. 0 multiplied by neg 1 plus this 1 multiplies 2. Thereafter, we'll say that our AB is equal to, here we multiply, this times this one, we have a 2, plus this times this one, it's 6. This times this one, it's negative 1, plus this times this one, it's actually going to be 4. This times this one, it's 0, plus this times this one, it's 3. This times this one, it's 0, plus this time this one, it's actually 2. So lastly, we'll say, as we add them together, finally our final answer will be the addition of what is inside now. We'll say 2 plus 6, which is going to be 8 here. This one is going to be positive 3 This plus this one is going to be 3. This plus this one is going to be 2. So this is the value of AB. This is how we multiply matrices. Matrices, we multiply them row by column. Row by column. That way is the manner that we can arrive at an answer. So the first row multiplies the first row multiplies the first column. The first row multiplies the second column. We come to the second row multiplies the first column. The second row multiplies the second column. This is how we solve. This is how we multiply matrices when we are dealing with 2 by 2 matrices. So you see what happens. How do you multiply?
Just wait. Okay.
You done that one? Yeah, so let's look at the way they can also, another way, like we can also find out that if asked the question this way, where in the first place we had a 2 by 2 matrix multiplying a 2 by 2 matrix. And this time around we're having a 2 by 2 matrix multiplying a 2 by 1 matrix. And what do you think would be the result? Sometimes people have thought about this for a long time. And this is why I'm saying that most people try to say, no, multiply 2 by 2 matrix and we have a 2 by 1 matrix. And people have said that the result will be a 2 by 1 matrix formed when these multiply each other in form of a matrix. Let's find out here how can we find out the solution for such a problem when it comes to multiplication of matrices. The way we have AB, we maintain it. We say AB is equal to, we start with A, open bracket, matrix A is 1 and 2, 0, and we have a 1 here. B, we attach the B, which is 2, and we have a 3 here. And then we start multiplying. The rule does not change, it's row by column. So we'll say that our AB is equal to 1 multiplied 2, 1 multiplied by 2 plus 2 by 3. Then we come to the second row here, which is 0 and 1, which is here. We'll say 0 multiplied 2 plus 1 times 3. Then we'll say that our AB will be equal to, this times this one, it's actually 2, plus this times this one, it is actually 6. This times this one, it is 0, plus this time this one, it is actually 3. So finally, the value of the matrix AB will be equal to, when you add the 2, we're having 8. When you add the 2, we're having 3. So this is the matrix. And this matrix here is what we're referring to as a 2 by 1 matrix. So this is the answer of this particular problem. So the emphasis here is that when you multiply a 2 by 2 matrix by a 2 by 1 matrix, the result is 2 by 1 matrix.